In this video, we look at examples where we take a function of complex looking functions and try to pull out information from that equation. In particular, we want to identify the parent function, some common function, some place to start, and then the transformations that are applied to that parent to give us the complex looking function that we have. So the first thing is, what are transformations? Transformations come about through arithmetic, adding, subtracting, multiplying, or dividing a number, and specifically a number. So when you apply arithmetic to a function, one of these four operations, it's well known what happens to the graph of that function. They are useful because their behaviors are common and well understood. Okay, and they can be applied to any function. The function we apply transformations to, we will call parent functions. Okay, so our parent functions will be very commonly known functions, and our transformations will also eventually become very commonly known to us. And with that combination of these well-known parent functions and these well-known transformations, we can graph countless functions using the same ideas. Okay, so we don't have to learn a new technique for every new function. So that's what we're going to practice here. We're going to start by practicing with parent functions. We start by identifying parent functions. And the way we do that is we strip away all the arithmetic to leave behind one higher order operation on just x. Okay, so when I say arithmetic, again, I mean add, subtract, multiply, divide. Those are not higher order operations. Square root, absolute value, those types of things are higher order operations. Okay, so that's what we're going to do here. Let's see if we can practice this. I'm going to list several functions, and then we're going to go through and identify the parents. So we have 6 complex looking functions here, and we want to identify the parent for each. So if we look at our first function, I'll take the most time with this first function, and I want to know the parent. I need to strip away all the arithmetic. So multiplying by this negative, I'll strip away. Adding 2, I'll strip away. And adding 4, I'll strip away. And what's left behind is this higher order operation, absolute value, with an x inside. That's our parent. So y equals the absolute value of x is the parent function. Okay. Functions are always y equals, so y equals the absolute value of x as the parent. Let's do this again on the second example. Let me clean this function back up real quick. In the second one, I need to strip away the multiplying by 2 and the subtracting of 3, and all I have left is x and the operation applied to x's squared. So x squared will be my parent function. So y equals x squared. One operation on x. Next, I need to strip away the multiply by 3 and the subtract 4. And what's left is x to the third power. So that's my parent function. Next, strip away the multiply by negative, another multiply by negative, and adding 3. And what's left is square root of x. So my parent is y equals the square root of x. Next example, strip away the multiply by 5 and the multiply by 1/2, and I'm left with the cube root of x. And this one's a little different. Strip away the multiply by negative, the multiply by negative, the plus 1, and the minus 4, and I'm left with f of x. So y equals f of x. You may see this sometimes. You may not, depending on what course you're taking, what book you're working out of, but I wanted to show you that your parent function does not have to be one of these well-known parent functions, one of these common algebraic functions here. It could be some generic f of x, and that may be applied in different ways. Okay, so now let's move on to these same functions and let's start identifying y transformations. So we've identified the parent functions. Next we're going to identify y transformations, and then last we'll identify the x transformations. So we're going to look at the same functions and identify the y transformations in a correct order. That's key. What do we know about y transformations? Well, let me tell you. Y transformations occur outside of the parent operation. We just saw that the parent operation is always one operation. The y transformations occur outside of that operation, and they follow the order of operations. Okay? Y transformations are the easiest. That's why we're starting with those. Let me go grab our functions and we'll get started. So our first example, our parent operation is the absolute value operation. So I need to look outside of that to find my y transformations. So my y transformations, I'll list here. So I look outside of my parent operation. I've got what's happening first to the absolute value is multiply by a negative and then add 4, and those are exactly my y transformations. So multiply by -1 and add 4 in that order. First multiply by -1 and then add 4. Now I think it's helpful when we actually get to graphing in a different video, since these are y transformations, I like to emphasize that these are happening to y. So I'll say multiply y by -1 and add 4 to y. So you don't accidentally do those to x. Okay? So those are the y transformations. In our second example, the parent is the square function, and what's being squared here is x. So everything happening outside of the square is a y transformation. So we've got multiply by 2 and subtract 3. Those are my y transformations. So multiply y by 2 and subtract 3 from y. Okay? Next, my parent function is the cube function, and so all of this is being cubed. That's all happening within the parent operation, and there's nothing happening outside of the parent operation. That means that there are no y transformations for this function. Next, the parent function is the square root. The parent operation is the square root. Looking outside of the square root, I'm multiplying by -1 and adding 3. So multiply y by -1 and add 3 to y. Again, watch the order. They have to happen in that order. Okay, next. Parent operation is the cube root. All that's happening outside of that is multiply by 5. So my y transformation is multiply y by 5. Next, my parent operation is the f operation right here. And what's happening outside of that is multiply by -1 and then subtract 4. And notice how every transformation I wrote, I mentioned how it affected y, because these are y transformations. Okay, so not too bad. Look outside of your parent function to identify the y transformations. We'll see how these affect graphs in a later video. Now what I want to do is look at x transformations, which are a little more difficult, and we'll analyze the same 6 functions. X transformations, you can probably guess, occur within the parent operation. The transformations and the order are determined by not the order of operations. So let me write this. And mark it out so we don't accidentally do that, because that's a mistake everybody makes. It's determined by not what you would expect, the steps to isolate x, like in an equation. Okay, so it's not bad at all once you understand it. Okay, so let's go grab our same functions and do this again. So just like before with y transformations, we need to identify our parent operation, which in the first example is the absolute value operation. And so what's happening inside there is what we use to determine our x transformations. And the way we do that, let me extract what's inside, which is x plus 2, and pretend that that's in an equation. So pretend that this is x plus 2 equals some number, and I'm trying to solve this for x. How do we isolate x? In other words, what do? Well, we subtract 2 from both sides, and if we do that, we get x equals some number, right? X is isolated. The answer to how do we isolate x, that is your list of transformations. So in this case, we subtracted 2. So that's my transformation. Subtract 2 is my x transformation. That's it. Now it's a bit mysterious here on why that's the case. The idea is when you're dealing with x transformations, you're trying to figure out how to determine good values of x to plug in. So you need to get x plus 2 back down to just x. Every time you're trying to take what's inside the parent operation and how to transform it back to x. That tells you your x transformations. Now just like before, since these are x transformations, I would like to include the word x somewhere. So I'm going to say subtract 2 from x. Not absolutely necessary, but strongly recommended so that you don't get these operations mixed up with your y transformations. Okay, the next example, so this is our one x transformation, okay? In our next example, the parent operation is the square operation, and all that we're squaring here is x. So I'm going to take what's inside my square, which is x, and set it in an equation. Here, x is already isolated. I don't have to do anything. So there are no x transformations in this example. Okay? All right, next, inside my parent operation, well, my parent operation is the cube operation. Inside that is 3x minus 4, so I take that out. Notice I'm not taking the cube with it. That's my parent. And I pretend that it's in an equation that I'm trying to solve. Well, the steps to get x by itself would be add 4, which would give me some other number on the right, and divide by 3. And x would then be by itself. So those are my x transformations. Add 4 to x and divide x by 3 in that order. Okay? Next, the parent operation is the square root. Inside I've got negative x. If that were in an equation, to get x by itself, I would divide both sides by negative 1, and that's it. So my x transformation is divide x by negative 1. Next, my parent operation is the cube root. Inside I have 1/2 x. To get x by itself, you could say divide both sides by 1/2 or multiply both sides by 2. Either way, it's the exact same operation. And then x will be by itself. So I will say multiply x by 2 for my x transformation. Lastly, my parent function is the f function, or my parent operation is the f operation. Inside I have negative x plus 1. In an equation, I'm not going to write out the steps now, you could hopefully see, the first thing you would do is subtract 1 from both sides. So my first x transformation is to subtract 1, and I'll say from x, since it's an x transformation. Then to get rid of the negative, I need to divide by negative 1. So I'll say divide x by negative 1. And that is how you identify your x transformations.